All right, good morning. Hope you guys can hear me. Please send a message if there's any in the chat box, if there's any connectivity issues. Welcome to 220 online. My name is Seth Herzon. I'm in the chemistry department. I've been at Yale for about 12 years, 13 years. Taught this class several times, so hopefully we can, adapt to this format without too many hiccups. In thinking about how to put this together, I talked to colleagues both within Yale and outside of Yale. I actually didn't teach in the fall; I was on leave, and so I've tried to hit a balance that hopefully will still be effective, and also amenable to this virtual format. And that being said, I want to retain some flexibility throughout the semester in terms of the mechanics of the course. So I'm not going to change the evaluation really in any way. So, what's on the syllabus will stay, but how we deliver the lectures, how we interact might change if we can identify ways that are more effective. And, sort of on that note, very much welcome your feedback as we go through the course. And if you can think of ways to improve, I really want to hear about it. Obviously, it's going to be hard to sort of, meet everyone's needs simultaneously, but I'll try and consider the group in aggregate, and hopefully we can, have a great course. I think one of the advantages or one of the opportunities here is really to rethink how, these large lectures are delivered, and then also on your end to really think about, how you learn, sort of, rather than looking at it from the perspective like, okay, we're stuck online, let's say like, okay, this is actually now your second semester where you can think about changing your approach, improving your approach to your subject matter. And so, I think we should all be optimistic that come end of April, you'll have had an effective class, and maybe you'll pick up some study techniques and learning techniques that, when we go back to in-person lecture, will be helpful to you, and perhaps that you wouldn't have been able to originally, to test under those circumstances. So we're going to make the best of it. It's going to be fine. Hopefully you'll have some fun. I'll try to make it interesting. I know, a lot of you are probably not chemistry majors, and that's okay. But organic chemistry is very interesting, very rich subject. If you're thinking about going on, if you are a chemistry major and you're going on, this will really form a foundation for what a lot of what you're going to do in your advanced classes. So when you take P-Chem and quantum thermodynamics, you're going to sort of see examples from organic chemistry. Certainly you can go on and do advanced organic and take graduate classes and things like that. If you're not a chemistry major, if you're in biology, certainly, or if you're thinking about medical school, it goes without saying, every single script, if you're not getting an antibody or mRNA, you are getting a small molecule, and that's organic chemistry. So understanding structure and bonding reactivity, is very important in thinking about how molecules interact in biological systems. That's something that my group's really interested in. 99% of what we do is synthetic chemistry, but we also study, how these molecules interact with DNA and RNA and other natural polymers. So, all right. So we'll do a little bit of housekeeping, and then we'll start the first lecture. So what I'm going to do is have the chat window open during each lecture, and you should feel free to ask questions in real time using the chat window. I will be staring at a electronic pad here. And so what I've done is I've asked the TAs there'll be a TA in each lecture, and they will monitor the chat window and try to answer your questions. If any of those questions don't get answered in real time, please feel free to email me, and I'll follow up with you directly on that. We'll have office hours immediately following the Monday and Wednesday lectures. So basically, I'll just stay on the line and hang out until, if anyone has any questions or wants to talk about anything, I'll be available, and we'll use breakout rooms, to sort of try and get some privacy if that's appropriate. All right, so let me just spend a few minutes on the syllabus, and then I'll hopefully then we can just get right into it. So let's see here. And I'm not that old, so I think I'm reasonably effective with the technology, but you guys are definitely probably better than I am. So, all right, so here we go. So here's the syllabus. Goal is to provide you with an introduction to organic chemistry. Again, I shouldn't apologize for it, but a lot of what we're going to be doing is like the basic nouns and verbs. You know what I'm saying? And like the language. And like, it's like if you were to go to study French or something, you would spend, the first couple semesters sort of learning how, I studied French in high school and I can't remember anything, but, pronouns and whatever. But point is, we're going to have to do a lot of that to get you to be able to just talk about chemistry. And so, and that admittedly tends to be sort of the drier part of the course, but I'll try to keep that content as minimal as possible, such that we can focus on the really interesting stuff, okay? And so we'll talk about nomenclature, chemical reactivity, synthetic transformations. I'm gonna tell you something right now that I will say over and over in the course, okay? 90% of organic chemistry is hyperconjugation, okay? We're gonna get to hyperconjugation very soon. The other sort of 10, the other 10%, 8% of that is resonance and inductive effects. And so like I really mean it, like, it's not just, me just saying it. There are just a few concepts that if you can really nail them, you'll be fine. You'll be absolutely fine. Okay, and that's the goal. So, there's stuff you'll have to memorize, there's nomenclature, all that. But like, certainly if you forget, some specific transformations, or you're thinking about sort of hierarchy of reactivity of different functional groups, falling back on hyperconjugation, resonance, and inductive effects will usually get you to the right place, okay? So, so sort of at like a top level, it may seem like there's a lot to memorize, but it all rests on like a very consistent foundation of those three concepts. And so hopefully I can convey them to you clearly, and you can internalize them, and it will make the course a lot easier, I hope. Okay, so yeah, so we want you in April to feel good about organic chemistry. People always ask me what I did, and it's like what I do, and it's like I took organic chemistry. There's one of two responses, okay? One response is, oh, never took it, thank God. Second response is, oh, I took it, it was awful, okay? So I'm aware it's not everyone's favorite course, but hopefully, we're gonna make it as pleasant as possible. And I would argue that I have converted several non-chemistry majors to chemistry majors upon taking this class. So hopefully we can get a couple of you to come over to the dark side. All right, so we're gonna do, so the lectures. So again, it's, it's like canvassing people, no pun intended, asking them how, what's the best way, most effective way to do these online lectures. And like everyone, you get as many answers as people you ask. And so I tried to sort of split the difference in terms of doing it in real time and doing it, pre-recording. So, I think there's obvious advantages in terms of where people are to having all the lectures pre-recorded. it does effectively double your time on Zoom, which I don't think anyone is super excited about. So Monday and Wednesday, we're going to lecture live. And these lectures will be recorded, and I will get them onto Zoom, or sorry, onto Canvas. Fridays, I'll lecture. There will be a Friday lecture. I will record that independently of you guys, and then you can watch that at your convenience. What we're going to do during the Friday lecture time is an in-class problem solving, and we'll break you into, the format of that will be to break you into small groups, and we're going to assign the groups. You'll be with the same group until each midterm, and then following the midterm, there will be a new group. So you get to interact with different people, and the idea here is that not only us, like we will be around, both of the TAs will be here on Fridays. We'll try and go through and help you with your reasoning, but then also talking to different colleagues. Hopefully you can get tips and tricks, as you sort of put your heads together, okay? So on Fridays, what I'll try to do is, open it up to questions, okay? And also, if there are any sort of, it'll be like sort of housekeeping. So if there's any sort of things I didn't cover that I need to just touch on, if there's anything that I presented incorrectly or in a way that could be clarified, I'll do that. If there are sort of repetitive questions that I'm getting that it's clear, like I didn't get something across, I'll try to address them in front of the entire class, okay? And then we'll spend the rest of the time doing the quiz. And I call it a quiz, it's a quiz in name only. It's, we've assigned some points to make sure people come and participate, but the real goal is not to evaluate you on every Friday, but the real goal is to get you talking chemistry with your classmates and with myself and the TAs. And so hopefully that'll be effective. All right, so preference selection, you guys are probably experts with that. You need to sign up for a section. As I said, I'll have my office hours on Monday and Wednesdays. You should have taken Gen Chem before coming here. If you haven't, you should shoot me an email, please. We have 2 excellent teaching assistants. Both of these students are graduate students in my own group, Maddie Frischling and Ziki Zhu. And so they'll be leading the sections and will be available to help you. There's also a peer tutor assigned to this class, so Nishida Amacharla. And these are the texts. Many of you have used Sapling. I'll be assigning Sapling problems to go with each chapter. And those problems will be due prior to each midterm exam. So you don't necessarily need to do them every week, although I'd recommend that. But if things get backed up, you'll have extra time. You may want to think about getting molecular models. Organic is very visual, and it's very helpful to see things in 3 dimensions. What I will do as your instructor is I will basically show you a program known as Spartan, which is a molecular modeling program. I can actually pull it up real quick. This is a molecule that I've been playing with. And you can see it. The gray is carbon, red is oxygen, the yellows are hydrogen. This is actually Ziki's molecule. Well, no, this is the wrong one, Ziki. Anyway, computational chemistry has gotten to the point where you can get these bits of software. So Spartan Student is $25. I'll see about getting that distributed to you guys for those of you that are interested. To be honest, it's faster than building a model in a physical model. It's just easier to build these things on the computer. And then there's a lot we can do. We can calculate energies and look at conformers, and this tends to be an excellent learning tool. And when we start to talk about conformations of organic molecules, I'll be showing you lots of Spartan images and working through it. And again, going back to what I said in the beginning, this is actually an advantage of the remote function, is that I can just, show you what's on my screen and walk you through it. Okay, so so the course will be out of 1,000 points. So every point is a point. There's no real fitting of points at the end of the semester. There will be 3 synchronous in-class examinations, midterms. And, things always come up, during regular times. Certainly now we need to be more flexible. So we're going to take the 2 highest scores that you have on your midterms, and we'll drop the lowest, okay? And so for those of you that, make all through, do great on the first 2 midterms, congratulations, you can coast on the last one. If you're sick or you're unable to take the midterm, we'll take that as your drop, okay? There'll be a final exam that's worth 400 points. There's the sapling points, and then the median overall grade in this course, I said will be set to an A-. That's, I'm not going to hold you to that, in the sense that if people are performing very well, we can move that up, but it'll be A- will be the median, sort of in the worst case scenario, okay? Some standard stuff on regrading. If you want a regrade, you have to ask within 2 weeks, please. That's just to kind of put a hard stop on everything. And then, there's this academic integrity statement that I circulated last night, and I'd like you to read it, sign it, scan it, send it to your TA. I don't want to say too much about this, other than, I've heard a lot of, I've heard some bad stories from people at Yale and outside of Yale, in terms of, trying to keep everyone performing, doing their own work and everything, and not being successful. And, it's not my job to police you. You guys are all young adults, right? And you want to be treated like adults, right? And it's not the TA's job to sort of be doing detective work. So I'm just going to be really blunt about this, which is like, everyone starts this class from the standpoint of, you want to do well, you want to learn, you're excited to learn, you're going to be honest about your work, and we're just going to go from there, okay? And, it will come out in the wash. In the sense that, if you're a chem major, you're going to need to know this stuff. If you're thinking about med school, you're going to need to know it for the MCATs. It'll even out in the fullness of time. So I really don't want to turn it into a situation where we're sort of, playing games and trying to, figure out, who actually solved the problem and where the answers came from. And we're just going to trust you guys, okay? If we find out that there's a violation, we're going to deal with it. But everyone's going to start from a position of trust. And I'm asking you to respect that. And, again, if you're having problems, one of the opportunities of this semester is like, I'm pretty much always available, we can do a Zoom call, we can talk chemistry, we can talk about whatever you want. TAs are constantly available. You have a peer tutor. There are a lot of resources. So, let's not worry about the grades. Let's just focus on the material, and I guarantee you the grades will come, okay? All right, that's all I want to say about that. Statement on diversity, you feel free to read through this. So these are the chapters that we're going to go through. And if I get my book, so I get my textbook and I go to chapter 11. Okay, I'm at approximately page 550. Okay, so there's a lot of material. Okay, it's very important that you keep up in this class because it is 100% cumulative. And So I'd really encourage you to try and stay in front of the readings. You know, there's no sort of funny business. We're just going to go through the chapters as they appear in the book. If you go to the calendar, what I've done is if you double, hopefully you guys can see this on your calendars, and if you can't, please advise. If you double click on it, you'll see you get the Zoom link, but then you also get the assigned readings for the lecture, okay? And the sapling problems. And as we go, there are no assigned book problems, but like if we go later in the course, you'll start to see them. So again, we're not going to grade these, but these are the problems that I'd like you to be able to solve, okay? And so you should look at it as a challenge and as a test of what you've learned, okay? All right, so yeah, pretty much everything's on the calendar, and hopefully it'll help to sort of keep everything going smoothly here. All right, what else? Yeah, that's really it. This is, I guess, all the days laid out. I just pause for a second for this aspect, for the housekeeping. If there's any questions, please go ahead and answer them in the chat, and then after that, we're going to start with the lecture.
I was wondering when section will start.
All right, if there's no questions, then I'm going to start lecturing. So,
Professor Herzen, I think you
here
froze.
we go.
Hey,
all
sorry,
right,
so I did ask a question.
Is that?
Step one, need to get the tablet connected. Let me see here.
Seth?
Stop the share. And then start the share. Go to the whiteboard.
Professor?
Okay.
I'll text him.
Hopefully you can see this. And resume share. All right. Oh no. Let me see here. Someone, Zeke, can you say something?
I'm talking actually. Can you hear me? Oh, you can hear me? Okay, you couldn't hear me like 2 minutes ago. So I think one student asked when will the discussion section start?
Yeah, I think discussion is going to start this week, right? And so Zeke and Maddie will be leading those sections, and the days and times are on here. So 2 today and then 2 tomorrow. Okay. Obviously there won't be as much to talk about, but it'll get going.
Oh, actually, have you guys chose your sections yet? Oh, okay, nice.
Yeah.
It's like we don't actually know which one we're teaching.
Yeah, I think we can talk about that offline, but yeah,
okay.
You and Maddie
Sure.
can basically divvy it up. There's no one or the other, isn't that significant? I got a couple emails about people that hadn't signed up for section, and the expectation is that there's going to be a lot of empty space. And so once the initial sort of shopping period ends, you should be able to go in and sign up for a section. Sapling will be graded. Carolyn asks, how will sapling be graded? Sapling will be graded on the sapling website. They'll score you. We don't penalize for, there's no penalty for incorrect answers. So if you get it wrong, you can repeat the problem. And what we're going to basically do is adjust that sapling grade to 40 points. So yeah, here it is. So the final percent on your sapling, if you got 90% on the sapling at the end of the semester, you'd get 36 points towards your final grade. So that's how we'll test it.
So is it graded to completion, or is it graded like
if there's 10 questions and you get like one wrong on the first try, now it's like a 95% if you get it right on the second try?
I don't think the points decrease as you, yeah, I think it's all the same. You get the same points no matter how many times you answer the question.
Okay, so if we complete like the sapling assignment, then it's just like, that would be 100% effectively.
Yeah, yeah.
Okay.
Yeah, exactly. And that's, again, it's kind of like the in-class quizzes. It's not really to test and do points. The points are just to make sure everyone does it, but it's really to give you guys, it's mandatory practice. Okay. All right. All right. All right, here we go. You ready? I'm gonna do it. All right. Can everyone see the whiteboard? Yep. All right. Got my notes, got my whiteboard. I'm gonna slide over here. You might see cats walking by occasionally. We have 2 cats, Larry and Black Cat. We used to have 3. One of them disappeared a couple months ago. It was kind of sad, but Larry's very friendly and tends to like the keyboard. So anyway, here we go. All right, so we're gonna start with chapter 1, talk about chemical bonding. Okay. And, in all of chemistry, there are basically 2 types of bonds. You got your ionic bond and your covalent. Hello, yeah. And your covalent bond, okay? The ionic bonds, I'm not going to say too much about because as organic chemists, we don't really play with them that much. You're familiar with this probably. Sodium chloride, table salt is a good example of a ionic bond. Oh, one more comment. I see some of you writing, which is great. I'd encourage you to try and write as I'm writing. Again, right now, maybe not so important, but as we start to draw structures and things, it's a very visual subject. The more you can get comfortable drawing, you'll be better off. So try to keep up with the drawing. Obviously, you'll have the recordings, but it's good to sort of learn to do it in real time. All right, so yeah, right. So where was I? So sodium chloride is an example of an ionic bond. We typically find this when the atoms involved have different electronegativity. So okay, and I should sort of qualify this by adding a very in there. So typically what you're going to see for an ionic bond is you're going to have what we call a very electronegative element. We'll define electronegativity more specifically, but in short, it is how tightly an atom wants to hold on to its electrons, okay? So you'll have one atom that's very electronegative. You'll have the other that is not electronegative, that is willing to share or even give up its electrons. And we can call that an electropositive element. And you essentially get electron transfer between the 2 elements. And so if I expand on this sodium chloride example, sodium has 1 valence electron, chlorine has 7. And because sodium is electropositive and chlorine is electronegative, when they come in to interact with one another, you actually bounce an electron over to chlorine. So we get Na plus Cl minus. Okay. And we can draw this. We'll draw this like this. Okay. That is also how we draw covalent bonds. But what you sort of need to understand implicitly is that because of the difference in electronegativity, the electrons aren't shared. They've just gone from sodium to chlorine. And it's essentially a charge-charge interaction. So opposites attract. So it's a charge-charge interaction that holds the sodium and the chlorine together. Okay. Covalent bonds are much more interesting. Covalent bonds are all of organic chemistry. Okay. And this is where we have two atoms that are of closer in electronegativity, okay? And so the one that's less electronegative, it doesn't say, okay, I'm willing to give you my electron. It's like, no, you have to share, okay? And so the two electrons in a bond are shared between the atoms. Okay, and if I stick with, let's bring chloride along as an example, you can think of something like methyl chloride. So that is CH3, and I'm just going to lump the carbon and the hydrogens together because we don't really care about them at this instant. And then I'm going to have Cl attached, okay? And so again, we're going to take a deep dive into all of this, but suffice it to say that carbon is much more electronegative than sodium, and so it's closer to chlorine, and so they share those two electrons. Another way to put it is that the electron density is distributed around both carbon and chlorine in their covalent bond. Okay, and so this kind of brings me to the next item, which is what we call Lewis dot structures. So this is like, how do we actually draw a bond? What am I doing with these dots and these arrows or these lines? The dots, I'm showing the valence electrons. So, oops. Okay. The dots I'm using to show the valence electrons, and then if I want to simplify that, I can draw a line. Okay. And so if we start with the simplest molecule, dihydrogen, okay, so each hydrogen atom, let me not use that. I don't want to confuse you. Each hydrogen atom has one electron, right? And when those come together, they can form a bond. And so we can draw this out as something like that, okay? And so there are always going to be two electrons in a bond. And this is formally the Lewis dot structure, all right? And one thing that, as molecules get, what you're going to see throughout the class is as we get more complicated with the structures, we're going to have to simplify the way that we show them. Otherwise, we'd spend the whole class drawing out the Lewis dot structure of, isopentane or something. So it's really not practical. So the way that we simplify this is we just draw a line. So we have H, okay? We can go slightly more complicated and talk about methane, for example. Okay, so you've probably heard of methane. It's unfortunately, it's a greenhouse gas, right? Naturally occurring, also generated by farm animals in quite large quantities. it's more complicated because now I've got 5 atoms. So if I want to draw the bona fide Lewis dot structure, you'll see that it's going to take a bit longer. So I have 1 carbon, okay? And carbon has 4 valence electrons. And then I have 4 by H dot, okay? And so if I put these together in the Lewis dot structure, what I'm going to wind up with is something like this, okay? So again, that's our Lewis structure, okay? Even that is a lot for us to draw, so we're going to simplify that and just draw straight lines between the atoms, okay? And we'll come back to this. We're going to get into this, but of course, many of you will appreciate that methane is not a 2-dimensional molecule. It has space in 3 dimensions. And so if I want to sort of be more accurate in the way that I describe it, I will draw it like this. Sorry, there's a little bit of a lag here with this tablet. Okay. And you don't need to be overly concerned with this right now, but the bonds that are just drawn as simple lines, so these are in the plane of the board. And this wedge is coming out. And this hash is going back. Going back. Okay, and so we'll talk about why that's the case. Just for now, let me just say that that is what happens, and I'll explain why later. And that's a common thing. So most molecules, are 3-dimensional. There are lots of molecules that are 2-dimensional. Okay, and we'll talk about them. But most of organic chemistry involves molecules that sort of orient in 3 dimensions. All right, so let me go to another board here. Let's see if I can do this. Okay, there we go. And so there's another, so again, so I can draw a Lewis dot structure. That takes a long time, so I draw lines. So it's sort of like a simplification. There's another approximation that we're going to introduce in organic chemistry, and that has to do with the electrons that we, sort of concern ourselves with, okay? And so electrons in atoms are found in orbitals. Those orbitals have discrete energies. The electrons that occupy the highest energy orbitals, which physically are the sort of outermost orbitals with respect to the atom, are called the valence electrons, okay? And we are only concerned with valence electrons, okay? And there's a sound sort of physical basis for this, and that's really that the electrons in the lower energy orbitals are just stable and happy, and they don't want to be disturbed. Nature is always looking for the lowest energy pathways, the things that involve the least amount of perturbations. And so if I'm working with electrons in the outer shell that are highest in energy, okay, they want to get to a lower energy state, right? And so the way they do that is going to be by bonding, okay? The ones that are sort of more internal to the atoms in like the lower shells, they're already in low energy states. They don't really need to, they can't do anything to get any better, okay? So we're going to introduce this simplification where we're only going to concern ourselves with the valence electrons. Okay. And so this is very nice because again, it's a simplification. It allows us to just disregard everything that's going on sort of at the core of the molecules. Okay. And so let me give you a specific example here. Again, I'm going to bring it back to carbon. And so okay, so carbon has 6 total electrons, and the electronic configuration is shown here. Again, if this is ambiguous to you, I'll explain it in coming lectures. The 1s shell are the lowest energy electrons in carbon. Okay, and the 1s orbital is a spherical orbital. It's populated by 2 electrons. And then we go to the second layer, which is the 2s, okay? And so these are my valence electrons. And so I told you on the last, oops, sorry. I told you on the last slide that carbon has 4 valence electrons. That's in fact where they come from. So they're the electrons in the number 2 shell, okay? And the number 2 shell is higher in energy than the number 1 shell. And so nature wants to find a way to get those things into a lower energy state. And so basically when we talk about the chemistry of carbon, we don't even really think about the 1s shell, okay? Apologies, this is a little confusing. Hopefully if it is, it'll be clear very soon, okay? All right, so if we draw out the remaining orbitals in the 2s shell, I haven't shown any more orbitals because they are empty in a carbon atom, but there are in fact other orbitals in the 2s shell, and those are the other 2p orbitals. And so if I draw the full sort of configuration kind of, explicitly, okay, it would look something like this, okay? And so my 2s orbital is also spherical. And then I have 3 p orbitals, and these are like dumbbells. And so the assignment of X, Y, and Z is arbitrary. Nature doesn't make a distinction, but I'll just draw them like that, okay? And then these have a change in sign, and I'm only drawing this for accuracy. I'll explain it later. You don't need to worry about it, but the sign of the p orbital changes, so we tend to shade 1/2 of the orbital. The reason I get into this is that I've got these 4 orbitals now around carbon. Each orbital can take 2 electrons, okay? And so the maximum number of electrons that I can have around carbon is 4 times 2, 8, okay? And so that gets us to what you may have heard of as the octet rule, okay? So okay, so for most atoms that we're concerned with, so carbon, nitrogen, oxygen, that's most of organic chemistry. We're going to use this number 2 shell, and we're going to have a maximum number of 8 electrons around each atom, okay? and that is the octet rule. And so the basis for the octet rule is that in this number 2 shell, I have 4 orbitals, each can take 2 electrons ultimately. And so that equals 8, okay? You don't need to necessarily remember, we do need to know the orbitals, but we can just simplify it by saying, okay, you know, octet rule, don't want to have 10 electrons around carbon, for example, okay? We refer to that as a Texas carbon, okay? And it's not a good thing. Sorry if you're from Texas. I love Texas, by the way. You're going to follow the octet rule for essentially all second row atoms. So carbon, nitrogen, oxygen, as I said, hydrogen is a little bit different because it's in that 1s sort of regime. So hydrogen takes only 2 electrons, but all the others are gonna take 8. Okay. We have something that we refer to as formal charge, and I'll explain why it's called formal in a second, but essentially what you're going to find when we do reactions and like start working through chemistry is we need to keep track of all of our electrons, okay? And the electrons are going to move around, bonds are going to form, bonds are going to break, you know, but you can't add or make or destroy electrons in the, you know, in the process of a chemical reaction. So we use formal charges to help to keep track of that, okay? And the definition is going to be the group number minus the number of valence electrons, okay? And I'm going to define the valence electrons, and so I'm referring to a molecule here. The valence electrons of an atom in a molecule are defined as the unshared electrons plus 1/2 of the bonding electrons. Okay, so let me give you an example to make it clear, hopefully. So you think about ammonia, so NH3, okay? If I want to draw out a Lewis dot structure for this, I need to know how many valence electrons are in nitrogen and how many are in hydrogen. Hydrogen, we already said there's 1. Nitrogen is group 5, and so it brings to the table 5 valence electrons, okay? So oops, 3 by H dot. And then if I put them together, I get to a Lewis dot structure like that. Again, just to sort of iterate the line drawings, I can also draw this as N, H, 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 and then I'll show that pair of electrons that's actually not involved in bonding. So we call that non-bonding. And so how do I calculate the formal charge on nitrogen? So I need to look at the group number, which we know to be 5. So I'll just say FC on N equals 5, okay, minus, and then we look at the number of valence electrons, okay? And so we're going to look first at the unshared electrons. There are 2, so that's 2. And then we go to 1/2 of the bonding. So we can count up the number of electrons involved in bonding. So 2, 4, 6 divided by 2 is 3. So 5 minus 5 is 0. And so the formal charge on nitrogen is 0. And that should jive with intuition. We know that ammonia is a neutral molecule and, you know, it has no charge, okay? However, if I put ammonia into water, it can grab a proton from water, okay? And what I end up with then is what we call ammonium, NH4 plus, okay? And if I want to draw an electronic Lewis structure for this, it's going to look like this. Bang, 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 okay? And so I can also do the line structure just for good measure. So if I'm going to calculate the formal charge on nitrogen, I'm going to do the same calculation. So I'm going to look at the group number, which is 5, minus the number of unshared electrons. And so in this case, all of the electrons around nitrogen are shared. So that's 0, okay? And then 1/2 of the bonding electrons. And so there's 2, 4, 6, 8 bonding electrons. And so I take half of that, so -4. And so that, even I can do this math, that gets you to +1, okay? And so we say that the nitrogen has a +1 formal charge in ammonium ion, okay? And I'm gonna stop here, but I just wanna say one more thing about this. The reason we call it formal is because it is a bookkeeping mechanism. So the charge, to be more accurate, the charge is not localized on nitrogen. It is in fact delocalized through the whole ammonium molecule. But the idea behind the formal charge is that it just allows me to keep track of charge as I'm doing reactions, as I'm building structures and changing them. Okay, so you always want to figure out the formal charge. It's important to recognize that this is not implying that I've got all of that charge focused on one atom. The molecule as a whole has a positive charge. Okay. All right. It's 10:17, so I will stop the lecture there. I will, as I said, I'll stick around. If anyone has any questions, I'm happy to try and answer them. Otherwise, if you don't, I'll see you on Wednesday. And I hope that you go out and have a little bit of fun in this snow. Okay. All right. Thanks, everyone.
Thank you.
Thank you.
Thank you.
Thank you.
Yeah.
Professor Herzon, I just had one quick question. So you know how you said that there's going to be like on Canvas as we get further along, like problems that we should are recommended to do in the chapters. Will solutions to those problems be posted at any time, or can we find the solutions?
Yeah, they have there's a solutions manual that you can purchase from Loudon. So I'm not going to actually post them, but
okay.
Yeah, you can get the manual and they should all be in there. Yeah.
Okay. Could you maybe post a link to them, the correct manual on Canvas, just so that we get the right one?
Yeah.
Thank you.
Sure. Yeah.
I also had a question. I was wondering what the format for the group quizzes would be. Is it going to be something on Canvas that we get the day of on Friday, or is it a Google Doc?
It's going to be more low tech than that. I'm probably going to send you a PDF, and you guys can fill it out, put together an answer. Someone from the group, scan it or just take a photo and upload it.
And is it going to be due at the end of the class, or is it okay, thank you.
It'll be done. It'll be due at the end of class. Exactly.
And then do we have our first group quiz this Friday, or are we waiting a week? Okay.
No, there'll be a quiz on Friday. Yeah.
I have a very minor question. When you were talking about that carbon atom, shouldn't that be 2 electrons distributed in 2px and 2py instead of both in 2px? I thought.
Yeah, I drew them both in 2px, didn't I?
Yeah.
Yeah, my apologies. That should be, let me see if I can edit this.
Yeah, 1 and 1.
Yeah, yeah. Good catch. Thank you.
Oh, and just to make sure, we need to pay for sampling, right? Because I've never used it before.
Yeah,
Sure.
it's, I think it's like 40 or 50 bucks or something.
Yeah, right. That's fine. I just want to make sure I'm getting the right thing. And also I seem to be able to like see all the questions assigned already. So I just want to make sure like that's the correct class. I thought like
It is. I just turned them all on.
Oh, okay. I see.
Yeah, because otherwise I'll forget. And then, yeah, so you can knock your socks off. Yeah.
Awesome. Thank
Yeah.
you very much.
Hi, I just had a question about practice. So throughout this course, do you recommend just doing like the practice problems in the textbook? Is there any other like material that we should focus on to prep?
I think between, you know, between sapling and what we're assigning in the textbook, you should be in pretty good shape. Yeah, if you wanted additional problems, I would recommend, you know, go on Amazon and get another organic book. And the one that I really like is by Maitland Jones. And you can play the same game where you just get that book and get the solution manual and then work through it. You know, I would wait and see how you feel after getting through what we've assigned, and then, you know, if you need to, but it's not going to hurt, right? Because it's going to be same material but different questions, so it'll help.
Okay, all right, thank you. Oh, actually, I had another question. So for our exams that we have, the midterm exams, do you know the format of how we'll be taking it?
Yeah, so the midterms will be synchronous, and what we'll do is we'll send you guys a PDF like right when class starts, and then you'll take them in real time, and then we'll give you a window, you know, 5 or 10 minutes to get the PDF uploaded at the end. Obviously, if there's any technical issues, we'll work around it, but that'll be the general idea.
So would we print out the exam or would we just write it on separate sheets of paper?
Again, I'm gonna basically keep the format identical to what we've done when it's in a physical class. So if you can print it, that's great. You know, obviously not everyone has a printer that they can get to quickly. So if you just, you know, blank paper or lined paper, it'll be fine.
Okay.
Yeah.
Thank you so much.
Yeah.
Okay, I'm leaving, Seth.
All right. I don't know
Bye.
who he is, but I'm gonna sign off. All right, so yeah, so we'll do sections this week. I think it'll be a lot of review. There's actually some stuff that I didn't get to, so maybe I'll send you and Maddie a quick note here and just talk about the topics. I'm gonna cover them I'm still gonna cover them on Wednesday, but you know, since you don't really have too much to talk about, maybe you could like do a first pass through it.
Sure. Yeah.
That'd be helpful. Okay.
Okay.
All right. Cool, man.
No, see you.
Yeah, bye. All right. Who's A? Is that the tablet? Or is that someone?
Go to full screen.
What's full screen? You. Allen Park, yeah, I don't know where that is. All right, Alan, I'm signing off here. All right, how do I turn off? All right,
Back to, oh, there you go, back to meeting.
right, just gonna do a hard quiz.